So in CONCERTO, I am leading the work package 3, which is the objective is to develop multivariate vegetation variable data simulation capability, and the objective with this data simulation capability is to exploit Earth observation to improve the representation of the land carbon cycle. And in this work package, we decided to focus mainly on one type of Earth observation, which is a new type of Earth observation, which is SIF, which stands for solar induced fluorescence. And so we are using different approaches to assimilate SIF in Earth system model. At CMWF, we choose to use machine learning to interface this observation with our Earth system model. And one of the main results is we show that the use of SIF improves the representation of the vegetation dynamics over cropland. And here, on the other hand, CMCC, they use a more developed Earth system model called CLM, the Community Land Model. And they choose to have a process-based approach to assimilate SIF in their model. And they compare, recently they compare the SIF simulated by CLM with Earth observation dataset, and they found a very promising results. In Earth system model, the plant is playing a key role because it's doing the interface between the surface and the atmosphere. So of course the plant has a key role in the land carbon cycle. The carbon cycle is coupled with the water cycle and with the energy cycle, so it's even more important because having a good representation of the vegetation dynamic is key. It's something which is very important to be able to have an accurate representation of the interaction between the surface and the atmosphere. And for CONCERTO, the vegetation is a key player of the land carbon cycle. So having a good representation of the vegetation dynamic, it's very important in CONCERTO. We focus on one particular process, which is the photosynthesis. In the work package 3, it's the reason why we are using the solar induced fluorescence, which is a proxy for photosynthesis. And because we can now have a satellite observation of SIF at a resolution about 10 kilometers. So it allows to have, by assimilating this satellite product of SIF, it allows us to better represent the photosynthesis and the vegetation dynamic in our system model. So an Earth system model, it's a process-based representation of the interaction of between all the components of the Earth. So it means the atmosphere, the land, but also the ocean, and also the sea ice and other components. So nowadays it's very important to have what we call this coupled Earth system model, and to be able to represent the interaction between all the components. And so it's a reason why in CONCERTO, yes, so we are using this model, and particularly in the work package 6, plan is to produce a seasonal forecast using this coupled Earth system model. So the role of the work package 3 is really to provide a good representation of the vegetation for this coupled simulation.